Good day, pre-algebra. We are talking about equivalent fractions, which is going to launch us into proportions. And so let's start by defining equivalency. You've heard about equivalent fractions, you've used them before, but what does the word equivalence actually mean? It's different, it's close to, but different than equal, right? Equivalent fractions, you know, they're equal in a sense, but they're also different because the numbers aren't the same. So when we talk about equivalent, we're talking about something kind of specific. Anthony, you had your hand up. What are you going to say?
They can both be multiplied by 2.
What do you mean?
To be equivalent.
Okay, so you're talking about the process to make an equivalent fraction.
Yeah.
We'll get there in a second. What's the definition of equivalency? And you can close your computers, those that have them open. This is not a live stream. This is a recorded video. Mia.
Equivalent is like, that is like equal.
What is equal, though? That's kind of what I'm hinting at here. Because if they were truly equal, if everything about them was equal, we would just say equal fractions, but we don't. We say equivalent fractions. So what is equal about them? Penelope.
Like you can divide a number or multiply a number to get the other two numbers.
Okay. Again, that's kind of like the process to find it there. Let's kind of start here. So we'll come back to that. Let's take 3/7 here. And the directions say, write 2 equivalent fractions for each given fraction. And so Anthony and Penelope kind of re-say what you said for how we would create an equivalent fraction.
Oh, they can both be times 2.
Okay, so Anthony wants to multiply both the 3 and the 7 by the same number, in this case 2. And that's going to give us a new fraction. That is what? 6 over 14. Okay. Penelope, what were you saying?
You could also like divide it if you can.
Okay. So in this case, we aren't able to. But let's take 8/10. What would you want to divide? How could you use division here to get an equivalent fraction? Okay. So we can divide both 8 and 10 by 2. And that will give us the new fraction of 4 over 5. Okay, so notice that equivalent fractions can be found by using multiplication or division as long as you multiply or divide by the same number. It doesn't always have to be 2, just happen to be 2 for these first 2 here. Okay, but now get back to our definition of equivalency. I mean, 6/14 looks different than 3/7, doesn't it? The numbers are different, right? This is they're only 4 away here, they're 8 away here. 8/10 looks different than 4/5, yet we're using the equal sign. So the numbers are different, but what is equal with equivalent fractions? What is equal between 3/7 and 6/14 and 8/10 and 4/5? Everyone, take out your calculator. Take out your calculator. What operation is a fraction? Division, right? That fraction bar means division. So in your calculators, I would like you to take 3 divided by 7. Okay, and you get kind of a long, nasty decimal, right?
Yeah.
Okay, try and remember it as much as you can. And now take 6 divided by 14 and tell me what you notice. It's the same thing. Okay? In your calculators, take 8 divided by 10. This one's much easier to remember. Okay? 8 divided by 10. Now, remember that and take 4 divided by 5. So, what is equal about equivalent fractions? What is the same with equivalent fractions, Zoe? The answer is the same in decimal form, right? We can say that their value is the same. So equivalency basically means same value. That's all. Same value. right? The numbers are different. 3/7 is different numbers than 6/14. However, when you divide them into a calculator, it's the same value. Okay, same thing with 8/10 and 4/5, right? 24/36. What can we do to write an equivalent fraction here? And don't use 2. Use something other than 2, because we've already used that too much. Gregory. 3. Do you want to multiply or divide by 3? Divide by 3. So let's go ahead and do that. 24 divided by 3. 36 divided by 3. What do we get? What's our new fraction here? Enough of that. I don't know what to call it, just that. Enough of that. What do we get? What are our new numbers here? Our new fraction. Gregory. 8/12. Okay, let's do one with multiplication here. What do you want to multiply 24 and 36 by? Again, don't use 2. Anthony?
6.
6? Do you know what 24 times 6 is off the top of your head? It's fine if you don't. We could use 6. What would be a really easy number to use that we could do mentally? 5 might be an easy one. There's with these bigger numbers, though, I would argue there's even a simpler one than 5. 10. One of the first multiplication numbers that you learn is 10, right? Because when you multiply something by 10, what do? Just add a 0 onto it, okay? So if we have 24/36 and we want to make an equivalent fraction by multiplying by 10, put a 0 on each of them, 240/360. Go ahead and in your calculator, verify that all 3 fractions are the same value. Our original fraction of 24/36, then our first equivalent fraction of 8/12, and then our second equivalent fraction of 240/360. And you know they're going to be equivalent if you get the same value for each of them. And do you?
Yes.
Yes. What is the value? A gross number. Not as gross as it could be.
It's like 66667.
Yeah, 0.6 repeating. Okay. Well, why does it end in 7 though? Who knows the reason why your calculator tacks on a 7 at the end of it? Because your calculator can only hold a certain number of places, right? Like 8 digits, something like that. So what it does is it rounds. It rounds on the last one. In fact, this decimal is 0.6 repeating, okay? But your calculator being limited, since it runs out of places, it rounds up on the very last one. That's why there's a 7 at the end. But it really is 0.6 repeating, okay? Questions so far? Okay, let's kind of move on a little bit. It feels like we have a pretty good handle on this so far. So let's go down to, well, actually, you know what? All of you, write 2 equivalent fractions for 18/22 and 3/50. No, not that one. 18/22 and 8/5. Let's get an improper fraction here as well. So 2 fractions, 2 equivalent fractions for each of those, and we'll just take what you come up with. You can verify it with your calculator. And then we'll move on to proportions. I need to get like some waiting music, like some elevator music or like some waiting music I can just play while people are working. But that would really enhance my video experience, I think. Get some new subs. All right, who can share an equivalent fraction they wrote for 18/22? Gregory.
180.
Good. 180/220. Gregory multiplied both by 10, just tacked a 0 on each of them. That's an equivalent fraction. Penelope. 54/66. Multiplied each of them by 3 and got 54/66. So that is an equivalent fraction. Anybody else? I want to share theirs.
188 and 222.
188, 220. What would you multiply to get that?
Oh,
Because we know that 18 goes in 180.
I tried to multiply by 11.
Okay,
Yes.
which you could do. But if 18 times 10 is 180, 18 times 11 would be 1 more 18, which would give us 198. And if 22 times 10 is 220, 22 times 11 would be 1 more 22, which would be 242. And so that would be an equivalent fraction. Anyone divide here? Go the other way, Zoe? Okay, and you got 9/11ths. All of these fractions, if you put them into a calculator, have the same decimal value. They're all equivalent. Okay, good. 8/5. Who wants to share what they did for 8/5? Nolan.
16/10.
16/10. Double each of them. Perfect. Who else? Gregory. 24/15. Multiply each by 3. Fantastic. 800,000, 500,000. Excellent. Equivalent fractions. 192/120. 48/30. Excellent. All of these, if you divide them into a calculator, will give you the same answer. Okay? The same decimal value, which is what? Anyone do it? Anyone test it?
I know it works. I just know.
It does. What's the decimal value for each of these?
1.6.
1.6. Okay, 1.6. All right. So that now brings us to a proportion, which anyone know the definition or can describe what a proportion is? We're going to use the word equivalent now that we're experts on equivalency. Proportion is basically two equivalent fractions. A proportion is basically two equivalent fractions. So when we wrote 180/220 equals 54/66, that's a proportion. When we wrote 198/242 equals 9/11, that's a proportion. When we wrote 24/15 equals 800,000 500,000, that's a proportion. Okay? Any two equivalent fractions makes a proportion. And why that's helpful for us is we can now solve for a proportion, solve for a variable in a proportion. If I tell you that these two fractions are equivalent, 1/2 and n/60, how can you tell me what n equals?
60 divided by 2.
And why 60 divided by 2? You're right, but why'd you say that? Why'd you just guessed?
Yeah.
That was a tremendous guess. Fantastic. Tristan?
Are we on a half equals n/60?
Yes.
Well, the n would equal 30 because if it's 1/2, 30 is a half of 60.
Yeah, we can kind of look at that value of 1/2 and we can say, oh, okay, well, what over 60 is half, or what's a half of 60? What's 60 divided by 2, right? And we get 30. Another way we could use is what's called scale factor. How do we get from 2 to 60? We multiply by 30, right? Just like making an equivalent fraction, right? We multiply by the same thing. So if we multiply 2 by 30, we're going to multiply 1 by 30, and 1 times 30 equals 30. We're using this knowledge of equivalent fractions to help us solve for that variable. The next one, 12/15 equals n/30. What's n going to be? And how do you know? Yeah.
24.
And how do you get 24?
Well, because 15 times 2 is 30.
Yes. Using equivalent fractions again. Well, how do we get from 15 to 30? You multiply by 2. So what do you do to the numerator? You multiply by 2. You're making an equivalent fraction by multiplying both numbers by the same thing. Exactly what we were doing on the front side, right? Now we're just using it to solve for something that we don't know. And 12 times 2 equals 24. Okay? See if you can solve for n on the next two there. Right? I'll get you started. How do we get from 3 to 27? How do we get from 14 to 70? That's what you're kind of looking for there. What's that scale factor to get from one to the other? Good. If you're done, move on to the next four, where we can use division also to help us, or more multiplication. Okay, what do we get for n in the third one? Who wants to share what they came up with? 90. 3 times 9 is 27. So 10 times 9 is 90. And that last one there, kind of a thinker. Mia? 85. 14 times 5 is 70. 17 times 5, n equals 85. You're just making equivalent fractions all day long. Okay? The next one, the next set says now use equivalent fractions going right to left using division. So since your variable is in the first fraction now, rather than the second one like it was in the first set of four there, we can use division also. What's the scale factor to get from 72 to 12? How do we get down to 12? What do we divide by?
6.
Divide by 6. Which means divide 24 by 6, and what do we get? N equals? Everybody? 4. Right? 24 divided by 6 equals 4. All right, so division works also. What can we divide the next one by? Again, going right to left now. 99 divided by what is 33? 99 divided by 44 is 33? No. 99 divided by 2 is not 33. 99 divided by 3 is 33. Right? So the same thing here. Use that scale factor, divide by 3. What's 51 divided by 3?
No, okay, this is just a question. So like there's like also another way you can do this.
Yes. That's the best thing about math ever. There's more than one way to do it. And if you do it a different way and get the right answer, I applaud you. Okay? So we can talk about that, but answer my question first, okay? What's 51 divided by 3? Just in the interest of time, Ryan? 17. Anthony, what other method were you talking about?
So for that one, you do like the problem for that one, you do like 12 times 24 divided by 72.
Yeah, so cross products is something that we'll talk about later on. Okay, if you already know the cross products method and you want to use it here, you certainly can, right? But this is kind of a more mental way to do it. You know, you probably don't know what 12 times 24 divided by 72 is mentally, but you could probably figure out that 72 divided by 6 is how you get to 12, and then 24 divided by 6 is how you can solve for n. So cross products works, but if you don't have a calculator and don't have the time to work out those bigger multiplications, then this is another way that you could use. Okay? But yes, alternate methods. Excellent. Yeah.
I'm pretty sure we learned cross products like last year.
Yep. Good. That's excellent. And we'll come across it again. We'll use it in a little more advanced way. But yeah, if you know that method, that's going to serve you well. Already having that background in it. Your assignment for tomorrow, okay, is to finish these two that we didn't do here, And then we start to talk about proportions and how you'd use this in the real world, right? I set the proportions up for you. An example would be, who likes to bake in here? Who are my bakers? Oh, not many. Well, in baking, if a blueberry muffin recipe says you need 75 blueberries to make 8 muffins, but you've got a lot of people coming over, so you want to increase this recipe and make 40 muffins, why wouldn't you use 75 blueberries for 40 muffins if the recipe says you need 75 blueberries for 8 muffins? Why would it not make a whole lot of sense to, increase the number of muffins but keep the blueberries the same? Adrian? Right. It would change the taste of it, right? It'd be very unblueberry, right? So if it takes 75 blueberries for 8 muffins, how many blueberries would you need for 40 muffins? This is where scale factor comes in, or cross products, right? You're increasing the number of muffins by a scale factor of 5. So if you're multiplying the number of muffins by 5, it would make sense that you would multiply the number of blueberries by 5 as well. Okay, that's how proportions work in the real world. Yeah.
Well, can I say the answer?
Sure.
375.
It's a lot of it's a lot of blueberries. Okay. And then 2 more proportions that I set up for you, but you need to solve using equivalent fractions down below. That's the only homework for tomorrow. Let's play the number game. You've got 3 minutes yet to work on it now. I do need to see your work, so I need to see how you solve it. If you use cross products, show me. If you use equivalency, show me.
What if you use the calculator?
Show me what you put into a calculator. Okay? Show me what you did. If it's a calculator, show me what you put in. All right? That's how you math.